Business Calculus, Topic 4, Homework Problems 11, 38, 39, and 40. Number 11. We want to maximize the function f equals x squared plus y squared, given that x plus 2y must equal 5. Well, I want to put this in terms of all one variable, so I want to solve for, let's say, x here. X plus 2y equals 5 implies that x equals 5 minus 2y. This gives me a substitution for my x's here. So f now equals, parentheses, 5 minus 2y squared plus y squared. Now this is a binomial, and I want to use the binomial expansion rule. That'll give us a squared, which will be 25, minus 2ab, which gives me negative 20y, and b squared gives me plus 4y squared, and then plus the y squared. Now it's all in terms of y. I can collect my terms. 25 minus 20y plus 5y squared. Now from here, I'm going to to maximize this, I want to take a derivative of this and set it equal to 0. So the derivative of this function with respect to y will be negative 20 plus 10y, and then set that equal to 0. Negative 20 plus 10y implies 10y equals 20, and 10y equals 20 implies that y is 2. So 2 would maximize our original function f of x. Now, what is the x value that maximizes this? X would be 5 minus 2 times 2, or should I say x will be 5 minus 4, or x will be 1. So 1 for x and 2 for y maximizes the function f. So f would be 1 squared plus 2 squared, 1 plus 4 gives us that the maximum value of f, 1 plus 4, the maximum value of f would be 5. Okay. Now, we have a demand function which is negative 2 times the price squared plus 48 times the price. And the price must be between $9 and $15. We want to find the elasticity formula. The elasticity formula is found by taking the negative part of the price times the derivative of the demand function divided by the demand function. In our case, this will be p times the derivative of negative 2p squared plus 48p derivative. And that'll be all over negative 2p squared plus 48p. Alright, the derivative of the numerator would be negative 4p plus 48. In the denominator, I'm going to factor out one of those p's. So we'll have p times negative 2p plus 48. From here, we can actually simplify those two p's and get negative 4p plus 48 all over negative 2p plus 48. Alright. Don't like all those negatives hanging around out there, but we can fix that a little later. Okay. Alright, but this is the elasticity formula. We could distribute that negative there and actually make this a positive 4p minus 48. Yeah, I'm going to do that. And negative 2p plus 48 in the denominator. Okay. Now, elasticity for the price of $14. So if the price is $14, we put 14 into this function. We'll get 4 times 14, and 4 times 14 is going to be 56, then minus the 48, and then negative 2 times 14 is going to be negative 28 plus 48, and that's going to be, let's see, 8 in the numerator and 20 in the denominator, and this will be, I think, 0.2 over 5, which is 0.4. Alright, so this is inelastic, okay, because it's below 1. Finally, we want to maximize the revenue. Okay, well, let's see, what price would maximize the revenue? Let's take the elasticity formula, which was 4p minus 48 all over negative 2p plus 48. And we're going to set this equal to 1. This will give us the price that will maximize the revenue. This implies that 4p plus 48 will equal negative 2p plus 48. Oh, sorry, this should be a negative 48. Okay, I'm going to add 48 to both sides and then add 2p to both sides. We'll end up with 6p's and 96. Divide both sides by 6. This implies that p is going to be $16. So $16 would actually maximize the price, or maximize the revenue. Now, what is the revenue maximized to? Well, revenue function is always the price multiplied times the demand, which is negative 2p squared plus 48p. Okay, so already we have a little bit of a problem. This price is out of our price range. Our price range was $9 to $15. But let's keep going. Let's find out what the revenue would be. The revenue would be $16 and negative 2 times 16 squared plus 48 times 16. And let's see what that would be. Alright, 16 squared, then times negative 2, and then we'll add 48 times 16. Okay, and then we're going to multiply all of that times 16 itself. Okay, so we have a revenue that's about our maximum revenue is $4,096. Okay, let's look at number 39. Number 39, we're looking again at the elasticity formula, and then we want to find out what the elasticity is for $35. So this will be negative, and then the price will be p. Then we need the derivative of the 404 minus p all squared. We need a derivative of that, and over 100. And then the denominator, we need our 404 minus p all squared, and that'll be over 100. Okay, now the derivative of 404, I'm going to pull my 100 down here. In fact, my 100s will cancel. So I'll have minus p. The derivative here will be 2 times 404 minus p, now to the first power. And then chain rule will be 404 minus p derivative. And all this is still over 404 minus p, all to the second power. Okay, the derivative of this will be 0 and negative 1. This negative 1 I will multiply with this negative, which gives me positive. And now I have a positive 2p. I have a 404 minus p to the first power and 404 minus p to the second power. These will simplify down to just a single 404 minus p in the denominator. And this will be my formula. Now, what about the price being $35? What's the elasticity of that? Well, let's put in $35 for price, and this will be 2 times 35 all over 404 minus 35. Okay, so 70 for the numerator divided by 404 minus 35, and I get elasticity of 0.1, let's say 0.19. Okay, and that's definitely elastic. Oh, sorry, inelastic, should I say? Inelastic. Okay, so that's good. So we can definitely raise that price a bit. Now, what should be the daily maximum daily revenue? Well, I'm going to take this function right here, my 2p over 404, which is my elasticity formula, set that equal to 1, and solve. So this is going to imply that 2p equals 404 minus p. I add p to both sides. That implies 3p equals 404. And 404 divided by 3, 404 divided by 3 is going to be a price of $134.67. Okay, $134.67. And this would actually maximize the this price would maximize the revenue. What would the maximized revenue be? Well, price times demand function. And the demand function is 404 minus p all squared divided by 100. And so we need to put the price of 134.70 into the price here. So I'm going to store this number into X, and then I'm going to type X parentheses, there we go, 404 minus X again, close parenthesis, square that, and then divide that answer by 100. And we get a revenue of 97687 and about 80 cents. Okay. Finally, we want number 40. We want the elasticity at the price of $3,000. Well, we need the elasticity formula, which will be price, negative price, times the derivative of the demand function, and then over the demand function. Now the derivative of the demand function will be -2. So we end up with a -2 times a -p, which gives us 2p all over the denominator of 10,100 minus 2p. And now we'll put in a price of $3,000. So it'll be 2 times $3,000 all over 10,100 minus 2 times $3,000. And let's see how much I can do this in my head. So 6 grand for top, and this will be also a 6 grand minus this will be 4, and 100. Let's see here, and I'm going to divide all this. Let's see here. 6,000 divided by 4,100. Oh, elasticity is 1.46. So this is elastic. It's not inelastic. Okay, not good. So our daily revenue for all this work, using an elastic price. Let's see. Let's take 2p all over 10100. Sorry, that's not it. There's my elasticity function right there. So this will be 2p all over 10100 minus 2p. Set that equal to 1. I'll have 2p equal to 10100 minus 2p. And this will give me 4p equals 101, and divide both sides by 4. Okay, so 10100 divided by 4, which gives me a price of 2525. Okay, so yep, my price is way over. $3,000, way over. Should have been charging $2,525 to maximize the revenue. And to find the maximum revenue, we will put this into the revenue function. I won't complete that, but it's basically the price times 1010. Well, I guess I will complete it. This will be, we'll store this into X, and then we'll have X parentheses 100 minus 2 times X, close parenthesis. And this gives us a revenue 12,751,250. About $12 million. We put in the price of $2,525 price would bring us a revenue of about $12 million, close to 13.